when we last finished our notes, we left off with our summary of the radians and degrees. And just a couple points to reiterate. We are going counterclockwise on this circle. You can kind of see my arrow up there by the pi over 2. And what we've got is we start at 0, we went to pi over 2, then we go to pi, and then down to 3 pi over 2, and then back full circle to 2 pi. And so what happens is that our values, and remember radians are measured in terms of arc length, for radians in the first quadrant are going to be between 0 and pi over 2. And in the second quadrant, we're going to have our angles between pi over 2 and pi. And in the third quadrant, between pi and 3 pi over 2. And then in the fourth quadrant, from 3 pi over 2 to 2 pi. The values are going to be in the fourth quadrant. In terms of degrees, we put those in. So the first quadrant is between 0 and 90 degrees. And the second quadrant is between 90 and 180 degrees. And the third quadrant is between 180 and 270 degrees. And then the fourth quadrant is between 270 and 360. But really what I want to continue our focus on is the radian values. And remember, I stapled your papers wrong accidentally, so let's flip back to these examples. And it says, draw each angle in standard position, determine the reference angle, state the quadrant the terminal side is in, and find one positive and one negative angle that is coterminal to each angle. So the first example here is 3 pi. And before I really get into it, I want to point out that we're going to be following the same steps that we did when we were dealing with degrees a little while ago. This is just now in terms of radians. So the steps aren't going to be super different, but it's because it's in terms of pi, that's what separates it. So in terms of pi, it means that we're in terms of the radians. So if we start here and we look at this one, 3 pi. So we're going to start here. And remember, we go all the way around. Just on thinking again, we start at 0. Then we went to pi over 2. Then this is pi, 3 pi over 2. And like I said, the full circle is 2 pi. So there's 2 pi, but then we have to go one more pi. So there's our representation. Here's our initial side. And here's our terminal side. And what we see is that our terminal side is on the x-axis, which means what we're working with here is a quadrantal. And consequently, because we're working with a quadrantal, we do not have a reference angle. So the only thing that we can really look at here is the coterminal angles. And remember what we did with degrees. With degrees, we took our angle and we subtracted 360 or we added 360. But now we're in radians. So now we're going to subtract 2 pi from the original, or we're going to add 2 pi from the original. So when we look at that computation here, 3 pi minus 2 pi is 1 pi. If we want to get really technical, 1 pi is still a positive angle, and our directions say find one positive and one negative angle that's coterminal to each. So if we want to make this negative, we can subtract 2 pi again, and 1 pi minus 2 pi is negative pi, negative 1 pi if you prefer. And over here, 3 pi plus 2 pi is 5 pi. Now quadrantals, slightly different, just because they don't have the reference angle and they don't have the quadrant. But let's take a look at example number 2, which is 4 pi over 3. So one thing that works well for me, and I hope that it'll work well for you, is that I can convert 4/3 pi, which is an improper fraction, into a mixed number. 4/3 pi, 3 goes into 4 one time, with 1 left over. 4/3 pi is 1 1/3 pi. So when I look at our picture here, remember this is 0 and this is pi over 2. Here's pi, there's 3 pi over 2, and then all the way around is 2 pi. If we put this in terms of fractions here, here's 1 pi, and then we need to go a little bit more, 1 and 1/3, which means that our terminal side is going to be right there. Here's our initial side along the x-axis. Here's our terminal side. And in fact, what quadrant is that in? Well, we are in quadrant 3. We can figure out the reference angle. The reference angle is just this part that I just wrote in blue. Connects back to the x-axis. And in order to calculate that, what happens is we can take our 4/3 pi and we can subtract out a pi from that. Because remember, we went 1 pi. There's kind of that protractor. And then we went a little bit more. So if we convert this here so that we have a common denominator, pi is the same thing as 3 pi over 3. So our reference angle, 4 pi over 3 minus 3 pi over 3, is 1 pi over 3. That's our reference angle. We know we're in quadrant 3, so now what we have to do is we have to figure out, well, what are the coterminal angles? Well, once again, take our original angle, which is 4 pi over 3. And in fact, I'm going to write it side by side here. 4 pi over 3 minus 2 pi will give us a coterminal angle. 4 pi over 3 plus 2 pi will also give us a coterminal angle. But in order to combine these, we need to find a common denominator. So in this case, remember that between 3 and 1, our common denominator is going to be 3. Well, 3 in the denominator, 6 divided by 3 is 2. So, in other words, I took 1 times 3 to get the 3, so I took 2 times 3 to get the 6. So we have a common denominator now. And then we still have our 4 pi over 3 minus 6 pi over 3. And 4 pi over 3 minus 6 pi over 3 is negative 2 pi over 3. The nice part, if there's any nice part, because some people don't care for the fractions very well, is that once we determine that 6 pi over 3, which has our common denominator in it, so we can combine those two terms, over here, when we're finding our coterminal angle, our positive coterminal angle, is going to be the same value. 6 pi over 3 is going to allow us to add these two together. And what we end up with then is we end up with 10 pi over 3 for our other coterminal angle. So I'm going to write these down here below just in case you can't read them. We ended up with negative 2 pi over 3. And we also ended up to be 10 pi over 3 for our coterminal angles. One negative angle and one positive. That's coterminal to 4/3 pi. 5 pi over 6 is our next radian. that we're going to work with here. And it may be helpful, again, just to label so far what we know. We know 0. We know pi over 2. We know pi. Not a very good pi. Try one more time. And we know 3 pi over 2. And then if we come full circle, it's 2 pi. Well, we need to find 5/6 pi. So again, it goes back to this fraction idea. And 5/6 is not quite a whole. And this is 1 pi. The 1 pi is a whole. So when we draw our picture, we're going to end up here with our terminal side over here in quadrant 2. To calculate out the reference angle is going to be this part only. So if you look, it almost looks like, with the blue and the red, that I have a complete protractor there. So originally there, one way to look at it is I can say that the complete protractor is pi, and then we need to subtract out the 5 pi over 6, because we don't need the red part of the radian, we need the blue part of the radian. Well, that's going to require us to find the common denominator again, but luckily 6 divided by 6 is 1 pi. Easy enough to find the common denominator. And then we can subtract 6 pi over 6 minus 5 pi over 6 is 1 pi over 6. There's our reference. But then we need to find the coterminal. So we still need to be familiar with our fractions here. But what we do to calculate is we take 5 pi over 6 minus 2 pi and 5 pi over 6 plus 2 pi. And now we have to find our common denominator. But once we find it for one, we can use it for the other. Well, the common denominator between 6 and 1 is 6. So we don't want to change the value of 2 pi. So since now our denominator is 6, we need to multiply our numerator by 6. 2 times 6 is 12 pi. So we have 5 pi over 6 minus 12 pi over 6, and that equals negative 7 pi over 6, in case you won't be able to read it on my blank here. But the nice part, like I said, is now that we know that 12 pi over 6 is the same thing as 2 pi, when we come to add over here 12 pi over 6, well, 5 pi plus 12 pi. Remember, we just add the numerator. We don't do anything to the denominator. We get 17 pi over 6. One positive coterminal angle and one negative coterminal angle. So lastly here, we have negative pi over 2. Remember that negative tells us the direction that we're going to go on our graph. So in this case, what's going to happen is we're going to go clockwise. So we're going to go this way. And here's our initial side. But here's our terminal side. And what we see once again is that we have another quadrantal. And consequently, we do not have a reference angle. But what we also want to do is we want to figure out our coterminal angle. And again, originally we have the negative pi over 2. And we're going to add 2 pi. And then we have negative pi over 2. And I went backwards here. Let's go back here. Negative pi over 2. Negative pi over 2 minus 2 pi. Negative pi over 2 plus 2 pi, and it doesn't matter. We just have to find one coterminal angle, one positive and one negative angle that's coterminal to each. And we're finding the common denominator. And the common denominator between 2 and 1 is 2. So we want to make sure that we keep that equation in balance, so to speak. 4 divided by 2 is 2. So we're good there. And we have negative pi over 2 minus that. If you prefer, remember that's negative 1 pi over 2 minus 4 pi over 2, which is negative 5 pi over 2. Let me write that underneath again so you can see it, and the blanket's a little tight. Negative 5 pi over 2. But once we've established that 2 pi is the same thing as 4 pi over 2, negative pi over 2 plus 4 pi over 2, it's negative 1 pi over 2 plus 4 pi over 2, will also give us our other coterminal angle of 3 pi over 2. So, what we explored yesterday, and we're still going to continue to explore, is angles and radians. But really what we have been discussing is that in a circle, a full circle, there's 2 pi radians. And if we leave it in degrees, that's 360 degrees. So, in other words, if we want to figure out a radian, we know that these two values are equivalent. And what we can do is we can divide both sides by 2 pi. And if we divide those sides by 2 pi divided by 2 pi is 1 radian. And we can simplify 360 divided by 2 pi. Well, 2 goes into 360 180 times. So 1 radian equals 180 divided by pi. It's the same kind of computation over here. 2 pi equals 360. That's not going to change. But we want to figure out what 1 degree is. So if we divide both sides by 360, 360 divided by 360 is 1 degree. And we can simplify 2 pi divided by 360. Well, 2 goes into 360 180 times. Pi over 180. So, to convert from degrees to radians, what we want to do is we want to put a pi back into the problem. So we would multiply by pi over 180. If we want to convert from radians to degrees, we want to get the radian value out. So that's when we would multiply by 180 divided by pi. But as we finish this, I will say that we are going to let you use your calculators on this calculation. So that should be helpful. But I'd just like to show you a little trick that sometimes is used in chemistry also. As we finish up with our examples here, our first one is 80 degrees. We want to convert from degrees to radians. So all we do is we take our 80 degrees and we multiply it by pi over 180. So the long way to do that is we can take our calculator and type in our fraction. We go 80 divided by 180 gives us 4 ninths. So this ends up to be 4 ninths, 4 pi over 9. But here's what happens in chemistry sometimes. Mr. Lambert would go, oh, I don't need the zeros. Cross them out. So you cross out the zeros. 8 and 18 are both even numbers. Well, 8 divided by 2 is 4. And 18 divided by 2 is 9. It does to me too. If we look at letter B, it's the same kind of process here. We take 140 and we multiply by pi divided by 180. We're converting degrees to radians. And like I say, if you like that shortcut, again, you can cancel out the zeros. You've got 14 divided by 18, and 2 goes into 14 7 times, 2 goes into 18 9 times. We get 7 pi over 9. Otherwise, you're going to type in 140. How about I type it in right? I'm going to type in 140 divided by 180. 7 ninths. Doesn't matter. If we have negative 30 degrees, we're converting it to radians, which is pi over 180. Again, you can cross out the zeros. You have negative 3 over 18, which is negative pi over 6. Or you type it in. Negative 30 divided by 180 is negative 1/6. Doesn't matter to me if you put the 1 in front of there. 100. 100 times pi divided by 180. Again, the shortcut is cancel out 1 0. 10 and 18 are both even numbers. 10 divided by 2 is 5. 18 divided by 2 is 9. 5 pi over 9. But you can type that in. It just takes longer. 100 divided by 180. But what we just did, we put pi's back into the problem, so we converted from degrees to radians. We can go the other direction. We can go from radians to degrees. So now we want to take out the pi. So this time it's going to be 2 pi over 3. And we're going to multiply by 180 divided by pi. And the pi's cancel out. You can type this in. By the way, just the shortcut version. 3 goes with 180 60 times. 60 times 2 is 120. Or you can take 2/3 times 180. There's 120. Converting 5 pi over 6 radians. We'll get this out eventually. 5 pi over 6 radians times 180 divided by pi. We want the pi's to cancel out because we want to convert this to degrees. So we don't want pi's anymore. The pi's cancel out. And then we can type in 5 6 times 180. See if this is faster. I doubt it. 6. Oh no, not faster. Which is 150. And to finish, negative 3/5 pi. Again, the negative just tells us that we're measuring in terms of clockwise. So it's negative 3 pi over 5 times 180 divided by 5. Pi's cancel out. And I don't know how many times 5 goes into 180, so I do need a calculator on this one. But, hold on. Negative 3/5 times 180 gives us negative 108 degrees.